first of all, they talk about adults, and then second of all, they talk about children. So what we're going to do is we're going to talk about the adults, and we're going to call the adults, let's say, X, and then we're going to call the children Y, so that we know what we're talking about. And then after you talk about that, there are two things that they deal with in this problem. They deal with, first of all, people. And when they deal with people, what they're saying is, we know that there are a total of 3,247 people. But we don't know how many adults and how many children. So what you do is you say, oh, here we go. This is what I know. I know that the number of adults, X, plus the number of children, Y, will be a total of 3,247. And now we see an equation just like in the first four examples. And then the second thing that they talk about in this thing is they talk about money. Now, for example, if you were purchasing a bunch of pencils, let's say you bought 25 pencils, and each pencil costs 10 cents, you would multiply those two numbers to find the total for the number of pencils you bought. Or in other words, 25 cents times 10 cents a pencil is $2.50. So we're going to do the same thing here. If we're talking about the adults, each adult in this situation is costing a certain amount. So I look at how much the adults cost, and the adults are costing $5, and the children are costing $3. So as I write my second equation, what I'm going to do is I'm going to say, hey, it was $5 for every adult and $3 for every child. And when I charge those amounts, they collected a total of $14,273. So these numbers of the 5 per adult and 3 per child are coming out of the story problem. At this point, once we have our two equations, we can set it up just like we've done in the past. All you have to do is write your matrices. So the matrices would be 1 from the 1x, 1 from the 1y, 5 from the 5x, and 3 from the 3y. Don't forget you always have your variable matrix. And that's equal to your, what sometimes people call the solution matrix, but it's not. It's just the constants that are on the other side. So 3247 and 14,273. And I'm not going to type this into the calculator, but that's how you would set it up. If you find your final answer on the calculator, which I'm not going to do with you because I've already shown you how to do that 4 times, you would find out that your solution to this is that your X and Y, which represent the number of adults and children, would end up being 2,266 and 981. So you can try that on your calculator, and this is saying again that this is the number of adults and this is the number of children who attended. So give that a shot on your calculator when you get a chance. I'm just going to set up number 6 and 7 just like I did for number 5, and then you can work with those as well. So let's take a look at number 6. In number 6, they have many things that are going on here. In this case, they are talking about on a trip that Dwayne, Marcia, and Parker all purchased certain snacks. So what I see is that they purchased candy bars, they purchased drinks, and they purchased popcorn. Those are the 3 things that they talked about. So as I work with this problem, what I'm going to do is I'm going to write down, hey, these are the 3 things I was talking about. So let's say what they are. Let's call the candy bars X. Let's call the small drink Y. And let's call the popcorn Z. If I do that, what I need to talk about is what's going on in each situation. So in each situation is actually talking about the different people. So in, let's say for example, I'm talking about Dwayne. Dwayne, when he purchased things, so here's Dwayne. So if I look at Dwayne, he purchased 2 candy bars, and he purchased 1 small drink, and he purchased 2 bags of popcorn, and his total came out to $11.85. And then there was, after Dwayne, Marcia. And Marcia bought one candy bar and 2 small drinks and 1 bag of popcorn, and that totaled, let's see, I think $9 it says. So as you look at these, you can kind of see them in the stuff here. So here's Marcia. And before it was Dwayne. And now I'm going to talk about the last person in our group. And the last person in our group is Parker. So Parker, when I talk about Parker, he spent $12.35. And he had 2 small drinks and 3 bags of popcorn. But notice how he didn't buy any candy, so that's 0 candy. And that was Parker. So each of our lines is representing a person, and the X, Y, and the Z is representing what they purchased. So off to the bottom here, I'm going to write down how I would set this up as an equation or as a matrices set of equations. So I would be writing down in the first matrix a 2, a 1, and a 2, and that would be Dwayne. I would do a 1, a 2, and a 1, and that's Marcia. And then I would do a 0, a 2, and a 3, and that's Parker. And don't forget that that's a 3 by 3 matrix in your matrices, because we have 3 variables, x, y, and z for the variable matrix, and that's equal to the dollar amounts on the right hand side of $11.85, $9, and $12.35. And these numbers again are coming from each of the different people. So we have Dwayne, who is represented by all the X stuff. We have Marcia, who is being represented by all of the Y stuff. And we also have Parker, who is being represented by all of the orange stuff. When you solve this, your solution is going to be that your X, Y, and Z is equal to 2.15, 2.05, and 2.75. And what this means is that X, which is your candy bar, they cost $2.15 a piece. Your Y, which was your drink, cost $2.05 a piece. And Z, which represented the popcorn, was $2.75 a piece. The last problem that we're going to set up based on what they talk about here. So here we have a school photographer taking pictures of couples at the prom, and she was charging $3.25 for wallets and $10.50 for portraits. And we're supposed to write a system of equations representing the fact that there were 10 pictures and the cost was $61.50. So if we talk about each of the pieces, let's say, for example, that we know that there's some wallets, and wallets we wanted to talk about, and we wanted to call that the X thing. And there's also some portrait size things, and those portrait size things we're going to call Y. And if we talk about the number of things that were purchased, so just the number of pictures, we know that the number of pictures is that they bought some wallets and they bought some portraits, and that was a total of 10, and that they bought these for a certain price. So if we talk about the prices, or money, for example, that they spent on each thing, we know that they spent $3.25 for the wallets, and they spent $10.50 for the portraits, which gave me a total cost of $61.50. So now we're supposed to set this up in a matrix solution set. The way that I would do that is I would write it as 1, 1, 3.25, and 10.50. Notice how there are no commas in any of these things. I would of course have my variable matrix, x and y, representing the pictures, the number of pictures in wallet size and portrait size, and that's equal to the cost overall of this and the number of pictures, so 10 for the number of pictures bought and 61 for the total price spent. And then if we solve this by putting this in your calculator, we're back to the 2 by 2 matrix and the 2 by 1 matrix, and what you end up finding out is that when you solve this, your x and your y, you find out that you get 6 and 4, which means that they got 6 wallets and 4 portrait size pictures.